This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. We're going to solve this trig equation, 2 sine of x minus square root of 3 equals 0. So what we want to do is solve for the sine of x, for instance. You could almost think of that as, how would I solve this if it was 2y minus square root of 3? Well, you need to isolate it, so we would add square roots of 3 first. So let's do that. Add square roots of 3 to both sides. This is basic algebra, right? So this gives me 2 sine of x equals square root of 3. And now 2 is the coefficient of sine of x. Notice this is not the sine of 2x. This is just the coefficient. So now we just divide by the coefficient. And I've got, I'm going to write it over here a little to the left, sine of x equals square root of 3 over 2. So either you've memorized where in 0 to 2 pi the sine of x is going to be square root of 3 over 2, and there's going to be 2 places. Or what I do is I draw a picture. I think, where's the sine going to be positive? And that's in quadrant 1 and 3. It's where the y coordinates on the terminal side of the angle are positive. So I'm going to draw a little picture here. Let's see, it would look like this. So that's one angle, and that is either 60 degrees or pi over 3, since we're asked to write it in radians, right? That's pi over 3. And where else? But over here, it's another place, right? So that's this angle, and in radians, that's 2 pi over 3. So there are 2 solutions in between 0 and 2 pi. Another way to do this, which would be harder, is if you could graph y equals the sine of x and see where the y coordinate is square root of 3 over 2. That's a little harder to see. When you have sine of x equals 0, it's easy. You're just looking at the x-axis, because that's where y is 0. So I think there's a little bit easier way to do it. But if you did graph it, because there's a period of 2 pi, that's why if you add 2 pi to any of these, you're going to get the same order pair, so the same y coordinate will tell you all of the solutions here, which is the second part. So the easy way to do that, is the way I think of it, is just the coterminal angles. If you add 2 pi, you get all the coterminal angles to pi over 3, and then you add 2 pi to 2 pi over 3, you also get all the angles coterminal to that. So we can write the solution as x such that, well, first x could be pi over 3, but, oops, it's an equal sign. X equals pi over 3, but we want to get all the possibilities that are coterminal, and so that would be 2 pi k, right? Or x equals 2 pi over 3 plus 2 pi k. And of course, we want to specify that k is an integer. Only works if k is an integer. We want, multiples of 2 pi, right? We don't want like half in for k, or 1/3 in for k, or some other number. So those are our 2 solutions when, first problem, in the interval 0 to 2 pi, right here. Okay, so there's only 2 solutions. And secondly, our solution down here, this satisfies all real numbers. Because there's infinitely many solutions, I need to use this variable k in my solution. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.